These are notes 2.2. I don't know if I made this clear, but in 2.1, when we made those segmented bars, okay, that was for categorical variables. Today in 2.2, we're going to talk how do we do it for quantitative? How do we represent quantitative data there? Okay, so what we're going to do is something you guys already know. We're going to use scatter plots. Okay, so a scatter plot looks like this. It has your explanatory on the bottom and your response variable on the top. So we're talking here about diamonds that are cut. So the weight of the diamond is our explanatory, and the result of the weight is the price. Okay, so you can see here the more a diamond weighs, the more expensive it gets. Okay, so we have those there. So let's look at explanatory and response here a little bit again. So average income and life expectancy. Okay, which one do you think would influence the other? What would we would start with, and what would be what we measure? Okay, so if we were setting up a scatter plot for this, okay, our x variable, our explanatory, and our response. Okay, so average income and life expectancy. We would probably look at somebody's income, okay, as our explanatory, is income, and then we'd look at how long they lived as our result. Okay, so you can take a guess what you'd see. Maybe we wouldn't see anything. I don't know. But as income increases, what happens to life expectancy? Does that also increase, or does it decrease, or whatever there? Okay, but we have our explanatory is our income, and response variable is our life expectancy. Okay, next one. The heights of husbands and the heights of wives in a sample of married couples. Okay, now does the height of a husband have an influence on the height of a wife, or does the height of a wife have an influence on the height of the husband? No, it doesn't really matter. So here you could use either way. You could put husbands here and wives there, or wives here and husbands there. So sometimes it doesn't matter. Sometimes there is a definite order. Okay. So how do you make a scatter plot? Okay. First, you're going to label your axes, create the scale in your axes, and then just plot each point. Okay. So we'll take this for example, 40-yard times and the long jump distances for 12 different students. I want to make a scatter plot of this data. So, and also you can tell here our speed is going to be our explanatory, and or the time there, and the response would be how long they jump. Okay, so first you would kind of think about, okay, if somebody's going to run this fast, how far do I predict they're going to jump for the long jump? Okay, so you'd start by making your axes, so x and y axes. Make sure you label which one's which, and then look at your times and distances and see what makes sense for you there. And then you just go through and plot each point. Okay. I'm going to make another video here how to do it on Desmos, and I'll include that here on the end. Okay. Now, when you look at these scatter plots, okay, remember how before we described things with SOCs, right? Okay, that was with just one variable. Okay, we're going to think SOFA. So the first thing we're going to think about is its. So is it a strong association, moderate, or weak? Okay, so we're going to think about how strong it is. So this one here is fairly strong. We can see a clear form of these here. This would be moderate strong. Okay, we're in between. Strong would be like if all the points were like really close together in a straight line. Weak would be if they're like scattered all over the place. Moderate is they have a form, but they're kind of just a little bit. Okay. Other one is outliers. Okay, so this doesn't appear to have any outliers. Form, okay, basically just Is it linear or nonlinear? Okay, linear means in a straight line pattern. Okay, we could have other forms that make parabolas or exponential or some other things. Okay, and the other one is association. Okay, basically, is it a positive association or a negative association? Positive means it has a positive slope to it. As one increases, the other one increases. Negative, it has a negative slope. As the x increases, the y decreases. Okay, so that's how we're going to identify, how we're going to describe these scatter plots. Now, the book, they use something a little bit different. They use DOFS, D-O-F-S, okay? You can use that as well. It's the same thing, just different letters. I like SOFA. I think kids remember it a little bit more. Okay, so let's describe some here. Okay, so if we look at this first one here. So, if we look at strengths and all that, okay? So, I would say, since they're all grouped together pretty well, I'd say it's a fairly strong one. Okay, so we would say this was a strong correlation. Okay, we would also go to outliers. There don't appear to be any outliers here. Okay, form. Now, if you would draw a straight line through here, I would think that's probably not the best form. If you remember back in Algebra 2, remember exponential in Algebra 1, I think you talked about it too, exponential curves. So we'll just say this is non-linear. You don't have to know if it's linear. I mean, just linear or non-linear is fine. You don't have to go exponential or quadratic or cubic or anything like that. Okay, and the association, as this increases, these numbers are increasing too. So it is positive. Okay, so this is a strong, positive, nonlinear relationship with no outliers. Okay, if we look at this graph, okay, we'll go through them again here. Strength. Okay, so these are a little bit more spread out, but you can still see the form of it. So I'll say this is a moderate. Strength. Outliers, I still say there's no outliers here. Form, I'd say that's fairly linear. And association is in a negative slope. As this increases, these numbers are decreasing. So we have a negative association. Okay, so this is a moderately negative linear relationship with no outliers. Okay, so let's look at this one here. Is there a relationship between the amount of sugar and the number of calories in a movie theater? So what you could do, and actually I'm going to do this in Desmos. I'm going to use this problem in Desmos here in just a second. Okay, so yep, pause it and get it in there.
Okay, so we're looking at the problem we were just doing about the amount of sugar and the amount of calories in movie theater candy. So we're going to look at that data, and I'm going to show you how to input the data here in Desmos. So we go to plus, and we're going to make a table. Our x's are explanatory, which we're going to use as sugar. So we're going to put those in there. And the y is the calories, the response, and it would be the calories. Okay, I'm going to pause this and type them in so you don't have to watch me type them in. Okay, so I've typed them all in. X is our sugar, Y is our calories. If I want to get a good look at the scatter plot, I hit this little zoom fit right here, and it gives me a good look at our scatter plot here. Okay, so if we want to describe this, okay, so we go through SOFA again. Strength, I'd say it's not real strong. So I'd say it's kind of scattered out here. So I'd say maybe possibly moderate to moderately weak relationship here. Outliers, looks like most of them are right in this area, so we maybe could consider this one an outlier right here. Okay, and then linear or nonlinear, I'd say linear is a good fit here. It doesn't seem to be quadratic or exponential or anything. And the association is positive, meaning the more sugar there in it, the more calories there are as well. Okay.